Air power in the India-Pakistan equation has quietly transformed from a supporting arm into the decisive battlefield domain. It is no longer just about fighters dogfighting or borders or bombers crossing lines on the map. Real contest today begins hundreds of kilometers before even the first missile is even fired. It begins in the silence, in the invisible spectrum, in radar shadows, electronic echoes, because modern air warfare is not about who flies faster anymore. It is not about who has the more fighters in the battle space. It's about who sees first, who detects first, and who jams first, and who controls the battle space before the enemy even realizes a battle has begun. And that is where airborne early warning systems come in. Now, these are flying radar stations orbiting at high altitudes, watching hundreds of kilometers in every direction, turning chaos into a single unified picture for the pilots. Without them, fighters are blind. With them, the entire air forces become networked hunting machines. So how did Pakistan Air Force go from having virtually no airborne early warning at all to building one of the most layered airborne early warning and electronic warfare ecosystems in the whole subcontinental region? How did it learn, sometimes very painfully, that radar gaps are not technical issues, but existential vulnerabilities? And how did encounters with systems like the American E-2 Hawkeye, the Soviet SA-2 guiding missiles, and Indian radar expansion shape Pakistan's entire doctrine of airborne awareness? This is not just a story of aircraft. This is a story of seeing the sky. Why were Pakistan International Airlines pilots flying secret missions over the Pakistani airspace? Why were Karachi's communication systems being jammed? When I say communication systems, I mean that telephones were being jammed while E-2s were flying around the space of Karachi. This is not just a story about aircraft or air forces. This is a story of seeing the sky and how Pakistan Air Force went on a journey to acquire airborne early warning platforms and becoming the formidable air force it is today. My name is Qasim and you're watching Radar Mode on Pakistan Connect. The story begins right after partition, not with machines, but with vision. In the formative years of the Pakistan Air Force, one of the most decorated and celebrated air chiefs of Pakistan, not just in Pakistan, but in the history of global aviation, Air Chief Marshal Asghar Khan, shaped a doctrine that would define everything that came after him. His philosophy was simple, but very powerful. A small air force must never fight blind. It must be built around the brightest and the bravest of officers, trained to think beyond numbers and compensate for technological disadvantages through awareness, discipline, and intelligence. And this doctrine holds true till this very day. This is where the culture of the PAF, the fabric, the texture of the Air Force begins to diverge from all other regional air forces. The focus was not just aircraft acquisition. It was systems thinking before systems even existed. But doctrine alone could not solve a problem which is growing: radar coverage gaps and the absence of airborne early warning. By the mid-1950s, Pakistan Air Force was operating in a rapidly changing environment under the US Military Assistance Program, receiving platforms like the F-86 Sabre, the T-33 Shooting Star trainers, the C-130 Hercules, and B-57 bombers. These aircraft transformed capability, but they also exposed a deeper truth. Modern air operations required early warning, not just strike power. What is early warning? This is a warning that you can receive way beyond visual range. If an enemy aircraft takes off, you should be able to detect and warn your Air Force so that they can take decisive measures. Before this, all the early warning systems were ground-based, which meant that they were unmovable, they were limited in range, and they did not have a 360 coverage like a flying radar does. And Pakistan just did not have it. The first major conceptual shock came not from a Pakistani system, but from encountering the reality of Soviet air defense doctrine. The Indians had acquired the SA-2 surface-to-air missile system, a Soviet-designed high-altitude radar-guided missile with an engagement envelope reaching about 15 to 25 kilometers, in some ideal cases 25 to 30 kilometers, in about 45 to 50 kilometers in range, depending on configuration. This changed how airspace denial worked globally. For Pakistani planners and pilots observing regional conflicts, one lesson became clear. Ground radar linked to missile systems could suddenly make entire corridors dangerous or invisible. And this is where something important happened. When Pakistani aircraft operating near contested environments somewhere close to Rajasthan, where there's two Indian air bases, I believe one is Bulleri and one is Bikaner. These air bases had installed the SA-2 systems. These were surface-to-air missile tracking systems, and when the Pakistani B-57s were flying in the airspace, they were not aware of these systems. And one of these aircraft was tracked by systems believed to be based on SA-2 radar coverage. It revealed something crucial. Ground radar had blind spots, but also unexpected reach, depending on terrain and integration. The idea that the aircraft could be seen before being seen became doctrinally important. But ground radar also was not enough, because ground radars bend with terrain, with mountains, curvature, and distance creates gaps. And in those gaps, aircraft can disappear. Pakistan Air Force began realizing that if it wanted to survive in a high threat environment like the India-Pakistan dynamic, it needed something above the battlefield, in the sky. It needed a radar that would be circling around the battle space and gathering critical information. It needed flying eyes. The breakthrough did not come in form of a dedicated AEW aircraft. It came disguised inside a bomber, the RB-57F Canberra. It was a variant of the Canberra itself, the B-57. It was an American high-altitude reconnaissance platform. It was modified with extended wings, so it could have more lift, it could spend more time in the air. And it had a very peculiar feature. It had been given 2 additional engines, and now these engines belonged to the T-33, which Pakistan had received under the Mutual Defense Aid program from the US. So the engine maintenance facilities and the overhauling, the Air Force already had. But this gave some additional engine power to this particular variant of the B-57. And this became the earliest airborne intelligence tool used in Pakistan's orbit of experimentation. In some configurations, it could operate at extremely high altitudes, somewhere towards 60 to 70,000 feet, approaching the edge of the stratosphere, providing long-range surveillance capability over vast distances. But the real innovation came when Pakistan Air Force engineers and American-assisted modifications turned variants like the B-57 into experimental electronic intelligence platforms, or EINT platforms. These aircrafts were not airborne early warning platforms in the modern sense, but they carried early stages of ESM, or electronic countermeasures, and reconnaissance systems that could detect radar emissions and identify coverage gaps. And here is where the story becomes strategically interesting. These initial flights revealed something alarming. Pakistan's ground radar coverage had serious blind corridors and blind spots along the western approaches, while India's radar expansion was becoming more continuous, layered, and increasingly integrated with Soviet origin systems. For the first time, Pakistan Air Force was not just looking at aircraft, it was looking at the entire battlefield, and with increased battlefield awareness. And it did not like what it saw. The next major milestone came with one of the most experimental phases in Pakistan Air Force history. Pakistan had joined CENTO and SEATO, both agreements under which the US and Pakistan came quite close in terms of military assistance. The US deployed the EC-121 Warning Star, early warning aircraft derived from the Lockheed Super Constellation. Now, the Lockheed Super Constellation was a normal airliner like the 747 or the Boeing 303. But this particular version carried a large dorsal and ventral radar, one above the fuselage and one below the fuselage. And these radars were capable in scanning the airspace in 2 directions, airborne targets, which were above, and also the surface activity which was happening below. So it was monitoring not just the air, but the ground underneath it as well. The radar coverage extended over long distances, creating one of the earliest true airborne situational awareness platforms. Pakistan Air Force was allowed to evaluate it in the early 1960s at Moripur, later renamed the Masroor Air Base. The Americans did not provide the full operational crews. They allowed for the aircraft to come in, but very limited just for evaluation with very limited support staff. And this is where the story becomes almost cinematic. As it happens, there was one institution in Pakistan which was flying the constellations, or the super constellations. This was the Pakistan International Airlines. PIA crews, including experienced captains and navigators, many of them deeply familiar with the constellation family, already operated civilian routes of PIA to New York, London, and Moscow. These were brought into the cockpit of these military aircraft. One of those pilots was reportedly related to senior aviation families who understood the aircraft deeply. During evaluation flights between late 1962 and 63, the EC-121 revealed its power in terms of electronic countermeasures and airborne early warning, but also its vulnerabilities. Because when the aircraft operated near contested environments, Indian radar operators reportedly attempted tracking and locking procedures at this particular aircraft. On at least one occasion, radar emissions from the Indian systems were detected by the EC-121 sensors, forcing the crew to alter their flight path and move back towards Pakistani controlled airspace. It was not just detection, it was interaction. And this moment exposed something critical. Airborne radar could see the battlefield in ways ground radar could not, but it could also be seen. And then came another anecdote that became part of the PF folklore. Pakistan, being the member of CENTO and SEATO, used to have military exercises, especially in air-to-air warfare, with the US Navy. At the time, you would see aircraft that you would never see in Pakistan, like the F-15s or the F-111 aardvarks. Very specialized US aircraft. In these exercises, when the US E-2 Hawkeye aircraft later operated in exercises with carrier groups near Pakistan airspace in the 1980s, their electronic emissions were so powerful that they reportedly interfered with the local telephone communication infrastructure in Karachi. In very simple terms, the phones just started ringing. You would pick up the receiver, it would still be ringing, you put it down, it's still ringing, essentially jamming the entire telephone exchanges in nearby operational areas. At the same time, there were instances where these aircraft appeared to disappear from local radar tracking. What would they do is they would climb up to 70,000 or 60,000 feet above the ground radar coverage, then they would turn off their radar. And as soon as they turn off, they're invisible to the ground radar, and then they would go to Peshawar, to Mianwali, all towards the western side of the Pakistan border. Terrain masking and electronic countermeasures reinforced the idea that airborne early warning was not just surveillance, it was also deception control and electronic dominance. Pakistan Air Force learned a fundamental truth here. If you cannot see everything, you're already losing. The real transformation of the Pakistan Air Force's airborne early warning and control systems began with the Saab 2000 Erieye system. This is a Swedish platform and it is built on a twin-engine turboprop aircraft modified with the Erieye radar system. It's an S-band system, active electronically scanned array radar, mounted in a fixed dorsal plank antenna, as you can see in the picture. It provides approximately 450 plus kilometers detection range for fighter-sized targets, with around 300 degrees coverage, allowing continuous airspace monitoring without mechanical rotation. As you must have seen in earlier airborne early warning platforms, the platforms would have a big round disc moving on top of the aircraft. That's a passive S-band radar, which means that the radar would move to track the targets. And it can track only one direction at one time. That is why it's moving. And you can see the one line moving in 360 degrees across the radar screen. This would move along with the radar itself. So the radar had to move to cover 360 degrees on all sides. The AESA radar is the next generation. Without going into too much details, because we have covered these details in our earlier program about radars, and AESA radars we've discussed in depth. These are static radars, but they have this wonderful new technology, a material being used called gallium nitride. This allows for 360 coverage without any mechanical movement, any mechanically moving components, which makes the range, the simultaneous detection, all that more powerful. Pakistan Air Force inducted these aircrafts starting in late 2000s, fundamentally changing its air doctrine. The number 3 Squadron, Angels, later the number 53 Squadron, Hawks, became operators of this particular system, turning the backbone of Pakistan Airborne early surveillance network. The Saab 2000 did not just detect aircraft. It fused radar data, tracked multiple targets simultaneously, and fed real-time battle space awareness directly into the fighter networks. For the first time, Pakistan Air Force could see the entire air picture without relying on ground radar alone. Alongside Swedish systems, Pakistan inducted the Shaanxi ZDK-03 Karakoram Eagle from China. This platform is based on a modified transport aircraft, as with most airborne early warning platforms. It is fitted with a rotating radome. Remember, this is the earlier technology. And Chinese AESA radar system providing full 360 degrees coverage, something the Saab system does not mechanically provide. It does it digitally. But this, the ZDK, has a rotating radar dome. This offers wide area surveillance, airborne command coordination, and extended endurance for patrol missions. Remember, jet aircraft always have a problem with the kind of fuel burn rate they have. And turboprops, or aircraft with propellers, usually have a more larger and longer endurance life in a single mission. Operating under the number 4 Squadron, the Predators, the Karakoram Eagle became a key node in Pakistan's layered AEW architecture. Unlike Western systems, it was designed with integration into Chinese command networks in mind, which later became significant in joint operational exercises like the Shaheen exercises and regional interoperability. The number 24 Squadron, the famous blinders, operate the Dassault Falcon 20 platform. The Falcon 20 is a French business jet modified into electronic warfare, electronic support measures, and signals intelligence platform. It does not function on an airborne early warning radar platform. Instead, it listens. It detects radar emissions, identifies enemy radar signatures, and provides electronic intelligence that complements the airborne early warning systems. It is part of the unseen layer of warfare, the electronic battlefield where radars are mapped, frequencies are catalogued, and enemy emissions become weapons of intelligence. In the 1990s, Pakistan Air Force faced a critical limitation. It attempted to evaluate multiple airborne early warning solutions, but political restrictions, particularly regarding US origin engines and platforms, and sanctions, created operational constraints. Aircraft that required American engine certification or maintenance approval could not be freely integrated, limiting procurement flexibility, which meant that any aircraft, some of which PAF was evaluating at the time, say for example the Saab Gripen, were using American engines, and the Americans were very free to cut off the supply parts, the supply chain, and the maintenance operations, so it was a risky procurement. At the same time, Indian radar systems were expanding in depth and integration, reducing Pakistan's reaction time window in simulated engagements. The gap was not just technological, it was strategic hesitation under constraint. By 2019, during heightened India-Pakistan tensions, electronic warfare became decisive. Pakistan's airborne systems played a central role in detecting, tracking, and managing airspace during engagements, for example, the Balakot strikes, while electronic countermeasures disrupted targeting cycles. Indian systems also demonstrated improved radar coverage, integrated SAM tracking, and airborne intelligence, surveillance, and reconnaissance support. Here I would like to address something that has been bothering me. Indian media channels have been raising a lot of hue and cry and surprise about claims of Chinese technical personnel assisting Pakistan Air Force operations and maintenance of Chinese originating platforms like the J-10C and the JF-17. This is nothing out of the ordinary. In fact, it is established that Dassault engineers, now Dassault is the company that manufactures the Rafale, they were on site and present, supporting and helping and assisting the maintenance and operations of the aircraft, of the Rafale aircraft that IAF was flying during May. I'm sure it wouldn't be out of the realm of possibilities that American engineers were helping and supporting and maintaining the F-16s that Pakistan has. There is nothing new about this. This is very common. These defense systems operate under global contracts, and their end-user license agreements have integrated engineers from supplier nations are embedded for maintenance, calibration, and software support. During the same period, French Dassault engineers were present with the Indian Air Force supporting the Rafale systems. And American contractors, I'm sure they could be present in Pakistan supporting the Pakistan's F-16 fleet under maintenance, under US oversight agreements. I'm sure you remember in 2026, we did a program on this, that the US approved a F-16 radar upgrade program. So I'm sure there were some American officials and engineers present on ground in Pakistan supporting those operations. This is no exception. It's a standard global operating procedure. I don't get what the surprise is about. However, coming back to our topic. As Pakistan Air Force moves beyond legacy AEW platforms, the shift is no longer just about improving radar range or adding new aircraft. The shift is doctrinal, and it is about moving from airborne early warning as a support function to airborne command, control, and electronic dominance as a central nervous system of the entire air battle. And I'm sure you realize that in the future wars, hopefully there is no war, and we all hope and pray that there's no more wars. But in the case of future conflict, we all know that the Air Force would be in the front and center of that engagement. This is where the next generation platforms begin to redefine the battle space. The Bombardier Global 6000, often discussed as a potential AEW electronic warfare carrier platform, represents a major leap compared to earlier turboprop-based systems like the Saab 2000 Erieye or even the transport-based systems like the Karakoram Eagle. Unlike propeller-based aircraft that typically operate in the 30,000 to 40,000 range, the Global 6000 is a high-altitude, long-endurance business jet platform capable of sustained operations above 50,000 feet. The altitude alone fundamentally changes radar geometry. The higher the platform, the farther the radar horizon extends, meaning it can see deeper into enemy airspace and earlier into missile or aircraft launches. But the real leap is not altitude, it is sensor fusion capacity. While older platforms like the Saab Erieye rely on fixed ASA plank radar optimized for wide sector surveillance, the Global 6000 class platforms are designed to integrate multiple sensor suites: ASA radar, electro-optical and infrared sensors, passive electronic intelligence arrays, and real-time satellite data links into a single fused battle space picture. In the context of India and Pakistan, this means one thing. Instead of just tracking aircraft, the system is now capable of tracking entire kill chains, which includes fighters, AWACS, ground radars, and even data link emissions from enemy networks. This is the transition from radar to cognition. Now compare this to China's Shaanxi KJ-500, one of the most advanced airborne early warning and control systems in Pakistan's partner ecosystem. The KJ-500 is fundamentally different from earlier platforms like the Karakoram Eagle. While older airborne early warning aircraft relied on rotating radomes and mechanically scanned radar concepts, the KJ-500 uses a fixed dorsal triple panel ASA radar configuration, usually arranged in a triangular geometry, that provides continuous 360 degrees coverage without mechanical rotation delay. This matters immensely in high-speed missile and fighter engagement environment because mechanical rotation systems introduce microseconds in refresh rates, while AESA fixed panel systems provide near real-time track updates. So the time taken from detection to reaction is massively reduced. The KJ-500 is also built on a more modern airframe, that is the Y9 transport class, giving it improved endurance, better payload capacity and electronic warfare systems, and the ability to operate at approximately 40 to 45,000 feet depending on the mission load. But its real strength is not just radar. It It is network command integration. We keep going back to the network-centric warfare, but that is what the future is. The KJ500 is designed as a full spectrum airborne command node. It can fuse data from satellites, ground radars, airborne fighters, and forward sensors and distribute targeting solutions directly to all our fighting platforms like the J-10C, the J-17 Block 3, and future systems, hopefully the J-35A, without those fighters needing to activate any of their own radar systems. This creates a doctrinal shift when fighters become shooters, not searchers, and that is a fundamental change in air combat philosophy in the India-Pakistan theater, and now it is being noticed by air forces all around the world. Now layer this into the evolving ecosystem. It is an often unlooked and overlooked fact, but the crucial component is the Hava standoff jammer. Hava standoff jammer is a Turkish airborne platform, but unlike the airborne early warning system, it is a dedicated electronic countermeasures platform. This represents the next evolution of airborne electronic warfare and standoff jamming capability. While normal electronic countermeasure platforms like the Dassault Falcon 20, which the blinders fly, focus on passive electronic intelligence and limited jamming support, the Hava standoff jammer platforms operate very aggressively in electromagnetic spectrums. Their role is not just to observe the enemy, but to actively deny, degrade, and distort the enemy sensing capability at standoff ranges, which means that they can be 200, 300, 400 kilometers behind the battlefront. In practical terms, this means that the Hava standoff jammer type systems can jam radar frequencies from outside the battle space without ever entering it, creating electronic corridors for friendly aircraft to penetrate deeper without being detected or tracked efficiently. When combined with AEW platforms like the Saab Erieye or the KJ500, the effect is multiplicative. One system sees everything while the other blinds everything else. This creates a layered architecture. The AEW aircraft becomes the eye in the sky. The standoff jammer, the Hava SOJ platform, becomes the fog of war generator, where all the information is being jammed or morphed or spoofed. The fighter becomes just the executor. And this is where the contrast with earlier systems becomes clear. The EC-121 Warning Star era was about simply understanding the airspace. The Saab 2000 era was about digitizing airspace awareness. The Karakoram Eagle era was about expanding coverage and redundancy. But the Global 6000, KJ500 and SOJ systems represent something entirely differently. They represent integrated battlespace control, a system where radar is no longer just detection. It is decision-making infrastructure, and in the India-Pakistan context, where reaction time windows can shrink to minutes because these are two nuclear-armed nations, neighbors right next to each other, the reaction times between firing and detection can be microseconds, in some cases just mere seconds. This transformation is not incremental, it is structural, because in modern aerial warfare, the side that controls the electromagnetic spectrum does not just see the battlefield, it defines what the battlefield even looks like. And whoever controls the waves controls the battlefield. If you look back at this entire journey, one pattern becomes impossible to ignore. Pakistan Air Force did not build its airborne early warning and electronic warfare capability in a straight line. It built it through gaps, experiments, through foreign platforms evaluated and returned, through political constraints, through trade embargoes, through military sanctions, and through moments where the battlefield itself exposed what the doctrine would not yet admit. From the early realization with the American assistance era that radar was not just a tool, but a limitation if not expanded into the air, to the EC-121 Warning Star, revealing what true airborne awareness looked like, to the RB-57 and B-57F experiments quietly mapping electronic blind spots. Every stage was a lesson written not in theory but in exposure. And then the shift. The Saab 2000 Erieye did not just give Pakistani Air Force a radar, it gave it continuity or vision. For the first time, the airspace was not a fragmented collection of ground stations. It became a connected battle space picture. The Karakoram Eagle added redundancy and reach, the Falcon 20 added the invisible layer of electronic intelligence, where radar emissions themselves became the signatures to be studied and exploited. And in the background, systems like the Hava Style-Off Jammer introduced something even more important: the ability to not just see the enemy, but to shape what the enemy can see. This is where modern air warfare stops being about platforms. It starts becoming about perception control. By the time you reach the modern era, Saab Erieye networks, Chinese KJ-500 integration, and emerging high-altitude platforms like the Global 6000, the concept of air warfare has already changed fundamentally, because now it is no longer enough to have numbers in fighters, missiles, or even speed. The decisive factor is who controls the electromagnetic picture of the battlefield. Who detects first, who fuses first, who decides first, and who blinds the other side at the exact moment decisions matter the most. This is where the India-Pakistan air dynamic becomes especially unforgiving, because both sides are no longer operating in blind skies. They're operating in overlapping radar bubbles, electronic countermeasure zones, and satellite-linked networks. And airborne command systems that compress reaction time into minutes to seconds. In that environment, airborne early warning is not a support function anymore. It is the battlefield itself. And electronic warfare is no longer a secondary capability. It is the silent layer deciding who gets to act and who only gets to respond. So when we talk about Pakistan Air Force's quest for airborne early warning and electronic countermeasure capability, we're not just talking about aircraft acquisitions or radar upgrades. We are talking about a complete survival shift from a force that once had to fly into uncertainty, with no eyes in the sky, with no proper radar coverage, to a force that now builds the sky as a managed, mapped, and actively controlled battle environment. Because in modern warfare, especially in our region, the first missile does not decide the battle. The first moment of awareness does. And whoever owns that moment owns everything that follows. This was all from Radar Mode this week on Pakistan Connect. My name is Qasim. If you found this episode insightful, please support the channel by liking and subscribing and sharing and commenting your thoughts below. In this age of invisible wars, awareness is not just power, it is survival. I'll see you again next week. Until then, stay informed, stay aware, and keep your radar on.